Good morning, students. I am NAVDEEP DHALIWal, faculty of Arya College of Engineering and IT, Electronics and Communication Department. Here in this session, I will be going to explain radar tracking. Now, to explain radar tracking, these are my session outlines where I will be explaining first what are the parameters that we need to calculate in radar tracking. Then I will explain you simple block diagram of radar tracking. Then I will explain working of that block diagram of radar tracking, and then I will sum up this session by giving little brief about types of radar tracking which is available. So let us begin this session with first point, that is parameters of radar tracking. So basically there are three parameters that we need to identify while we track object by using radar tracking system, and one parameter is range. Now range that we calculate based on transmitted signal and echo signal delay. So when we send signal based on transmitted signal and echo signal will be received by radar, so based on that delay will be able to identify what is range of radar. So this is one parameter. Second is azimuth and elevation angle. So based on beam of radar we will be able to identify what is azimuth angle and what is elevation angle. So beam of radar will justify azimuth and elevation angle, and that is so essential to identify direction of object. So in radar tracking system, direction of object that is being identified by azimuth and elevation angle, and distance of object that is being identified by range. And third very important parameter, that is frequency drift. So frequency drift that explains you what is velocity of object. So frequency drift that will explain velocity of object that is being identified by frequency drift. Azimuth and elevation angle that will justify direction of object, and range that will identify distance of object. So this is three parameters that is so essential in radar tracking system to identify position, motion as well as direction of object. So this is three parameters, that is what the basic agenda of radar tracking system. Now let us have block diagram of radar tracking system. So it will be more clear like what happens in radar tracking system. Now see here, I have a very simple block diagram and antenna is there, and that antenna that is directly connected to radar system. Now radar system is calculating three things. One is range, one is azimuth angle theta a, one is elevation angle theta e, and one is velocity of object vr. So ultimately these are the parameters that is being calculated by radar. Now based on error in angle that will be given to one system which is given idea about what is that angle, and that is what connected to servo motor. So if I say error in angle of elevation, that is delta theta e, and error in angle of azimuth, that is delta theta a. So that is what we give it to antenna, and based on that we'll be able to turn antenna position by azimuth angle correction and elevation angle correction. So see, if I revolve this antenna by this, it will be correcting elevation angle. Like see here we have target, so one aeroplane that is moving in direction towards antenna. So here antenna transmits a beam which is identifying this object. So when it identifies object, based on frequency drift we can identify velocity of object. Based on distance we'll be able to calculate range, like seen, transmitted and echo signal time period will justify range. And when it is moving towards to antenna, our radar system that will be having two errors. One is elevation angle correction towards to antenna, and another one is azimuth angle correction parallel to antenna, and that received by and radar, and this radar system is giving that correction to servo motor, and servo motor will change physical orientation of antenna so that this elevation angle as well as azimuth angle correction is getting done. So this is how direction is being modified to track this object, and we can have a calculation of range based on signal travel from radar to object, and echo signal will justify how much far this object is there. And based on frequency drift as per Doppler's effect we can be able to calculate relative velocity of object, and azimuth angle and elevation angle correction will justify exact tracking of target. So this is how complete system function. So here it should be clear to one, when somebody is calculating all those things, at that time one should focus about these parameters, where range calculation is very simple, but azimuth and elevation angle correction happens with respect to motion of object. So direction will change if object is in motion. So at that time we need to have calibration of azimuth angle and elevation angle, and that could be resolved by changing orientation of antenna which is being correcting to radar, which is being connecting to radar, and based on frequency drift we can be able to calculate what could be the motion of this target, and that is what we can calculate as per Doppler's effect. So this is what about motion that could be calculated by Doppler's effect. Now this is basic working and block diagram, and finally I will be just mentioning these methods. First is sequential lobing. That is one method by which we can be able to calibrate direction of object, so that is very popular method to calibrate direction of object, not position exactly but direction. And even conical skein as well as monopulse method that is being utilized to identify tracking of object by using radar system. So this is what about radar tracking system basics.